Hey folks, in this video we're going to do a HVAC load calculator using the EMS HVAC load calculation software. Now most people think that you've got to be a scholar of Archimedes in order to do all the math that's involved in doing a load calculation. Well, we're going to take it nice and slow and easy and show you how to do this thing without having to know a whole lot. Pardon me, but I still got my coffee here. So, first thing I want to do is show you how much math you've got to know. Do a load calculation, you only got to know how to calculate area and volume. Area is the length times the width. In this case, it would be this house right here is 34 feet by 65 feet. So we just multiply 34 times 30 times 65, and you end up with 2,210 square feet in that house. The second tough calculation we've got to do is calculating volume. Well, the volume is the length times the width, which is the same as the area, times the height. And if we do that, and move out of the way, 34 feet by 65 feet by 8 feet high is 17,680 cubic feet. Or, remember, length times the width equals the area. We could say the area times the height. Either way is right. In this case, it would be 2,210 square feet times 8 feet high, still 17,680 cubic feet. Now, that's the only two calculations you need to know how to do a load calculation. Now, you might have to do it a number of times, but it's going to be the same calculation all the time. So let's go ahead and get started on this load calculator and see what it's all about. Anybody can do a load calculation as long as you know some fifth grade math. Let's see if we can find it. Okay, so here's my site. It's hvacloadcalculator.com/home. And be sure to put the home in there, because if you don't put the home in there, you'll come to a different site. Alright, once you get there, you click on Login. And here comes a login page. We're going to do a residential load calculation, so you'll click on residential, enter your username, and enter your password. By the way, you will get a password. You'll make your own password when you purchase the program. I think this is a password. Can't remember everything. I'm getting old, you know. You click on login. It's asking me if I want to save it. I'm going to go ahead and save that password. So here you are, lo and behold, here's your load calculation. If you get lost, don't have any idea what to do, click on that link right there, and it'll show you step by step how to do the load calculation. But right now we're going to get rid of this. We'll go back to the load calculation. Now, as you notice, this section right here is your company's information. That's self-explanatory. And over here, we're going to put the client's information. So let's just say it's me. So the name is John White. There's his address. And his house is going to be in Raleigh, North Carolina. Already Leigh. And see, I think I spelled Raleigh correctly. Okay. So get another sip of this coffee so I can keep on going. It's a stressful calculation, man. Okay. I'm going to put in his phone number, the old 555 number. I'll put in an email address, and there's the day's date right there. Okay, the first thing it's going to ask you is your design conditions. What we mean by design conditions is what temperature do we want to keep the inside of the house when it's as cold as it's likely to get outside. Now, the indoor temperature you want to keep it at for winter time is going to be 70 degrees. The outdoor temperature depends on where you live. I told you this house was in Raleigh, Well, where are you going to find out how cold it gets in Raleigh? Well, let's go back to my website, click on degree days, and scroll down here to North Carolina if it hasn't moved. And there's Raleigh. It's telling you the outdoor design temperature for the wintertime is 20 degrees. Summertime, 99% of the time, it won't get any hotter than 92 degrees. So that's your outdoor design temperature for the summer. And keep in mind that over here that Raleigh's at 35 degrees. You'll need to know that a little bit later in this calculation. All right, so let's go back to calculator. There you go. So my outdoor temperature in the wintertime, design temperature is 20 degrees. And in summertime, we want to maintain at least 75 degrees in the inside. And outside, the outdoor design temperature, if you remember, was 92 degrees. And this is telling you that you got a temperature difference of 50 degrees in the wintertime and 17-degree temperature difference in the summertime. Over here, it just asks you what direction is the house facing. Well, let's go look at the house. Here's the house we're looking at. We went out to the house and we surveyed it, drew a picture of it, measured the windows and measured all the walls and what have you, and took a number of notes over here, which we'll get into in a few minutes. But nevertheless, the house is facing south. So we're going to go back to the load calculator, and this house is facing south. And it's kind of asking you how many square feet do we have in the house. Well, let's go back to my picture again. If I can find the picture. There it is. Okay. Total square footage is 2,256 square feet. So I'll put that down in there. Two, 2, 5, 6. Okay, it's time for another sip of this Joe here. I hope you're still with me. Have I lost you yet? Hope not. All right, how humid is the area? Well, Raleigh is moderately humid. So we select moderately humid. And how tight is the structure? Well, this house was built back in the 50s. It's pretty well built, so it's average tight. It's over 1,500 square feet, so it's average over 1,500 square feet. Put that on there. That tells you your air changes per hour. Okay, fireplaces in this house. I'm going to say, let's say we have one fireplace in there, and it's an average fireplace as far as tightness goes. The number of occupants, it's going to be a 3-bedroom house, so we've got 3 people plus 1, so we're going to say 4 people. That's a rule of thumb, number of bathroom bedrooms plus 1. We go to the next step. Now we're getting into some real math, folks. This is going to really trip you up. It's really not that hard, doggone man. Old man like me can do this. Okay, the section right here is talking about overhang characteristics. I'm going to come back to that in just a second. Right now I'm going to move down a little bit, and then we'll come and fill this part of the solar gain through glass. If this is a house where you've got the specs on the glass, which normally would only be a new house, got a tag on the window that tells you what the U value is in the SHGC. If you don't have that information, in this case, it's an older house and we don't have it, we do not check this box. So let's leave that box unchecked. The first thing it's asking here is what's the square footage of all the windows that are facing north or shaded. So we got to go back to our picture again. There you go. And this is your north side right here. So I got 12 square feet, that's a 3x4, plus 9 square feet is 21 square feet, plus another 12 is 33 square feet, 2 and a half by 4, it's 10 square feet, that's 33, that's 43 square feet, 53 square feet, and another 12 will be 65 square feet, if I'm not mistaken. So we're going to go back to my calculation. We put 65 square feet facing north. Now, it also says north or shaded. So let's go back to our picture again. You'll notice this window right here is facing east, but it's under a carport, so it's shaded. So we're going to have to throw that in with the north window. So that's another 12 square feet. So I've got 65 square feet, if you remember right. Yeah. And I got to add 12 more to that, so it's 77 square feet. Hope I still have you. Now we'll go down and take a look at the south-facing windows. I got 12 square feet plus 12 is 24 square feet. And here's another 24 square feet, which is 48 square feet. So we're going to put that's all 48 square feet facing south. Okay, let's see if we got anything facing east. Okay, facing east, I got 10 square feet and 10 square feet, 20 square feet. And we got 12 here, but remember, we've already put that in with the north, so we've only got 20 square feet. These two windows, the only two that are facing east. I hope I haven't lost you yet. Go back to my calculation. I'll put in 20 square feet. All right, let's go back and take a look at the picture again, see if we've got anything facing west. Ooh, that's 10 square feet right here facing west, and that's 12 more, so that's 22 square feet, and 12 more is 34 square feet. So go back to my calculator again. We'll say 34 square feet. Okay, 34 square feet. Now we got all our square footage of all our glass in the house. Let's go back and we'll select what kind of glass it is. This house has double window, has storm windows on it, so that's double. That's double. East facing is double glass, west facing is double glass. Move me out of the way. If you'll notice, the heat gain is 7,818 BTUs. That's the total BTUs coming through all the glass due to the outdoor heat and the sun shining through windows. All right. Another question here is, does it have reflective coating? In this case, it doesn't, but if you put yes, see what it did to my load? Almost cut my window load in half. Now, this does not have any. Now, I want to point one thing out here. If you happen to have checked this box and said, yes, you got the manufacturer specs, if you remember when we went back to my website and looked up the degree days, I told you that Raleigh was at 35 degrees latitude. That's where you got that, 35 degrees. And you look at the U value of the windows, let's say it was 0.30, and the SHGC, that's solar heat gain coefficient, is what it stands for. Let's say it was 0.28. Okay. And now it's changed all these HTMs, and now we went from 7,800 BTUs down to 3,196 BTUs. If you use them, the manufacturer specs, always keep this answer for your does glass have a reflective coating as no, because that's already factored into these numbers up here. All right. Ask you, do you have any skylights in it? We have no skylights. If you did, you'd put the square footage of the skylights, and you would select whether they were clear, tinted, or reflective. Okay, moving on down here. Get another sip of this coffee. Okay, where are the ducts located in this house? Let's put the ducts up underneath the house, so they're in a closed crawl space. depending on, do you want to use the existing ductwork, or are you going to put in new ductwork? Let's just say that we're lazy on this one. We're just going to use the existing ductwork, which is probably pretty dadgum old. And I imagine it's probably got about an R2 on it. It's unsealed, and it's asking you here what the area of the attic or the floor where the duct is located. Well, we got 2,256 square feet, I think. House is, I'll go back here. Step one. Yeah, 2,256 square feet is how many square feet's in it. Go back to step two. Okay. All right. The ducts are scattered around all underneath the house. 2256 is the square foot. Attic temperature. We don't have any ducts in the attic, so we don't have to put anything here. If the ducts were in the attic, go ahead and select one of these temperatures, and believe me, it's kind of a guesswork. All right, I promise you I'd come back to something later, which is up here at the top. Okay, we have entered in all the square footages of all our different windows and what have you. But up here, I don't know whether I want to try to do something here or not. Yeah, I'm gonna try something here. Draw. Okay. Imagine the sun was up here and it's shining like this on the window. This section right here of the window is shaded, and the section below it is unshaded. What this whole section up here is doing is determines how many square feet is shaded and how many square feet is unshaded, and both of those areas have totally different heat gains. So what we've got to do is enter in the information that it's asking here. Let me get rid of this thing right here, down here, if I can do it. All right. I think I'm going to go back where I was before. Get rid of that. Draw, clear them all. Okay, you got the idea. Okay. Now, that thing out of the way. Okay, the house, I'm going to go back to my house again. I can get rid of this thing. All right, this house has an overhang on it. Right here, and your back and the front got an overhang right there. And this has got an overhang right here, okay? All right, so front and back, we've got an overhang. That's north and south. So we'll go back to my calculation. Only on the south side, we've got east and west, there is no overhang, so that's 0. On the south side, I have an overhang. It's asking you right here, what's the distance of the overhang from the top of the window? That's from the top of the window to the overhang. In this case, it's going to be 6 inches. Now, look at 6 inches, decimally, that's 0.5. So, facing south is 0.5. And then it's asking you the length of overhang. How far does it stick out? That's B. Sticking out 1.5 feet, which is 18 inches. All right, and then the next question is asking you is, how many linear feet are there across the windows? You'll see this little sample, what do you call it, picture up here. You got 3 feet across the top of here, plus 5 feet, 8 feet, plus another 3 feet is 11 feet. We got to go back to our picture again. Okay, I got 3 feet plus 3 feet plus 3 feet. That's 9 feet. plus 2.5 plus another 5 feet. That's 2. So 9 and 5 is 14 feet, and another 3 foot is 17 feet going across the tops of all these windows. I told you it was going to get a little bit difficult, but this is as hard as it gets though. So we got 17 feet. Now, I shouldn't even have anything in here. We don't. If you have a north-facing overhang, you can leave that blank because it's going to be shaded the whole way, and it's not doing you any good. All right, so that's what we got. Now we're going back down here. Remember we had 78. Oh, sorry. I'm going to unclick this and you remember we had 7,800 BTUs using the generic windows, and now that we consider it, some of the windows have got shade, we dropped it down to 7,000 BTUs. And we have already got the ducts. By the way, the duct loss is for heating is 28% or 0.28, and the duct loss or gain for cooling is 31%. So 31% of your cooling is getting lost underneath the house through your ductwork. For the heck of it, let's just say that we change the ducts, put a R8 on it, and we seal them. Look at that, your duct losses dropped from 28% down to 7% for both heating and cooling. So that's pretty big. That's a tremendous difference. Well, I'm going to go back to where we were before. Unsealed. All right, continue to the next step. All right. By the way, that was the toughest thing you have to do, that whole calculation. All right, we're on step 3. We're almost home, folks. It's asking you for the area of the gross wall. By the way, a lot of people get confused. See where here it says area or linear feet. You want to put area in every one of these blank cells, except, it's a big except, a slab that's on grade, not below grade, but on grade. You will put the linear feet around the edge of the slab. Everything else on here is always going to be area. All right, so let's go back to my picture. Here's the picture. To get the area of the walls, you got to start somewhere. We'll start right here. Measure all the way around it. 32 feet plus 56 plus 24 plus 14 plus 10 plus 17 plus 18 plus 18 plus 18 plus 35. And it comes up to 240 square feet. You can add that up later if you want to check my math, but it is 240 square feet. Let me go back here. Okay, the perimeter of the house is 240 square feet all the way around that house. That's the length times the width. The width in this case is going to be 8 feet. It's 240 feet around the house times 8 feet high. So if you calculate, get this calculator, 240 times 8. It's 1,920 square feet. $1,920 square feet of walls. It's already told you got 179 square feet of glass. Doors. The house has got, go back to my picture again, 1, 2, 3 doors. And each door is 21 square feet, so that's 63 square feet. 63 square feet. That's your net walls after they take out the windows and doors. And my ceiling is going to be 2,256 square feet. And the floor is over a crawl. It's 2,256 square feet. Hope you're still with me. And come down here, it says infiltration, enter the cubic feet of the building. Well, I already calculated the cubic feet at one time. I know we haven't here. Okay, so the cubic feet is going to be the area times the ceiling height, which is 8 feet, right? I got 2,256 times 8 feet, 18,048 cubic feet. 18,048. Gotta get my numbers right. Okay, you'll notice I did not put any commas in here. If you put a comma in there, it'll mess up your calculation. So that's what you got. All right, now we're going to go back and select some insulation. My glass is double. Doors, they put storm windows on, storm doors on it, rather. The net wall, there's no insulation in the walls. The ceiling's got 3.5 inches of insulation in the attic, not much, which is R11. And there is no insulation in the floors. I think that's just about it. Got one other thing right here. Appliances. If there's nothing in this square, I recommend you just put 1,200 in there all the time. Unless the people that are in the house are in the catering business, they got 4 or 5 ranges going, and you might want to bump up the BTUs on your appliances. That's the amount of internal heat that's being put off by appliances. Typically 1,200 will work for about any residence. Okay, so here we go. We got the calculation. It's telling you that the house requires 84,000 BTUs to heat it. 37,000 BTUs of total cooling. And it breaks that cooling down between sensible and latent. Now this last column down here tells you that you need 3.6 tons. If you'll notice, that's probably closer to 3.1 tons. But this EMS load calculator is attempting to cover manual S. And what it's doing is making sure that the unit you put in is capable of handling the 33,000 BTUs of sensible plus and 44,000 BTUs of latent heat. If it can't, then you have to increase your tonnage by amount that will take care of it. So in this case, if you'll end up having to put in a 3.5 ton at least in here. Undersize it just a tad, but that's what I would put in that house. Tell the customers, and maybe more than likely you'll never worry about getting warm in there, but there is a possibility, but that'll be a very temporary thing. Okay, so that's what you got. Also, because the houses these days, if it's a new house, they're super insulated, it's very tight. Now you've got to introduce outdoor air. This calculation also considers all that into the calculation, and it has determined that you need to get a 52.56 CFM of air for the outdoors. And you can do that by running a duct, when you build your duct system, running a duct on the return side that goes to the outside and size it to your the static pressure that you'll use to design your duct system. Okay, folks, that's it. I'm going to go ahead and finish this cup of coffee. If you have any questions, you've got my number on my website. Let's go back to my website. There you go. Okay. I think my number. Yeah, it should be. We don't hide anything here. If you got any questions, you can always call me. Here you go, right there is mine. Okay? And if you want to, you can send me an email. Makes no difference. Okay, that's it, folks.